So today's lecture is on the fundamental theorem of calculus. So as you guys recall, guys, I'm starting. As you guys recall, what is a definite integral?
Let's see.
A definite integral is the area under a curve, right? So for a function f of x, the integral between a and b is going to be the area between the function and the x-axis, and between the lines x equals a and x equals b. So the fundamental theorem basically relates definite integrals and derivatives. And that's why it's called fundamental. It's like we're tying these two spheres of calculus together. We did the first semester derivatives, second semester integrals, and we're seeing how they're connected to each other. Here's how they're connected to each other. The definite integral of f of x from a to b is equal to the antiderivative of f evaluated at b minus the antiderivative evaluated at a.
Wait, sorry.
Well.
Okay, so this is the fundamental theorem of calculus. So in order to calculate the definite integral of a function, you take the integral, the indefinite integral, which gives you the antiderivative. I labeled that with a capital F, right? And then we evaluate it at b, the upper limit of integration, and we subtract its value at a, which is the lower limit of integration.
I'll understand it later.
Okay. So it's best to illustrate this with an example. All right. Do we all have this written down?
The classwork. Right.
It says classwork on it. It's classwork. So let's do an example. Suppose that we were trying to integrate x squared dx from 0 to 2. Okay. So geometrically, what this corresponds to is that we're basically just trying to find the area of the curve. And you guys know what x squared looks like, right? It's a parabola. We're trying to find the area under this curve between 0 and 2, where this curve in red is x squared. Okay, so this is the definite integral that we're trying to calculate. And we can do this using the fundamental theorem of calculus. So what is the antiderivative of x squared? The antiderivative of x squared is 1/3 x cubed plus c, right? Okay. And so to calculate the definite integral of x squared from 0 to 2, here's what we do. We take this indefinite integral, or the antiderivative, which is 1/3 x cubed. So we've done that a lot, right? We take 1/3 x cubed, and then we evaluate it at 2 and 0, and then subtract them from each other. So there's a notation that people came up with. They write a vertical bar to the right of it, and they write a 2 on the top and a 0 at the bottom. All this is telling us is that we're trying to first evaluate the function 1/3 x cubed at 2, and then subtract its value at 0. So it'll be 1/3 2 cubed minus 1/3 0 cubed. Okay, so that's what this notation means with this vertical bar here. It's just telling us that we're taking the top and then subtracting it from the bottom.
It was like stuff was like 4 and like 1, and then it just be 4 was at 1 minus 1.
What?
Like you would just replace use the thing.
Yeah, so you take the upper limit and you substitute it in, and then you subtract it with the lower limit and then substitute that in. And so the area under the curve, in other words, the value of this definite integral would be 1/3 8 minus 0, which is just 8/3. All right, so that tells us that 8/3 is this area here. All right, so that's a very interesting relationship between the derivative and the area under a curve, right?
Wait, that's kind of easy though.
It is pretty easy.
Is that just one for them?
Any questions? Vincent? Good question. So Vincent asks what happens to the plus c? The answer is that for definite integrals, the plus c doesn't matter anymore. The reason is we could think about it like this, right? If we had 1/3 x cubed plus c, and then we evaluated this from 2 to 0, the c's would just cancel out when we subtract it, right? Because c doesn't change between 2 and 0. So we would have 1/3 2 cubed plus c minus 1/3 0 cubed plus c. And that's still going to be 8/3, right? Because the c's cancel out. Huh? No. So for definite integrals, the plus c, you don't need it at all. Okay, so a definite integral is when you have limits of integration, right? So in that case, you don't need to worry about any constant. You don't need to worry about plus c. However, if it's an indefinite integral, meaning that the 2 and the 0 aren't there, then you do still need the plus c. Any questions? Let me do a harder one from the classwork. Any recommendations? Yes. 12 is too easy. Let me do one from the first page and one from the back. Let's do 5. Oh, okay, number 5 from the classwork. What does it say? We're trying to integrate 1 to 4 of u minus 2 over square root u. Okay, so let's try to first calculate the indefinite integral, right? So let's get rid of these limits of integration and see how we would calculate this. What would be the first step here? We should split it up into 2 fractions, right? So we should do u over square root u minus 2 over square root u du. I'm doing number 5. Okay, so after I split it up into 2 fractions, I can then write it as u to the 1/2 minus 2 times u to the negative half. Right? Because u divided by square root u is u 1/2, and then 2 divided by root u is 2 times u to the negative half. All right, anybody have the integral for this? Good. 2/3 u to the power of 3/2. All we do is we take the power and then we increase it by 1 and then flip it, right? So that gives us our coefficient. 1/2 plus 1 is 3/2. Then reciprocal of 3/2 is 2/3. How about the other one? Help you guys. This will be 4 times u to the 1/2. And then we have a plus c, right? Because this is still an indefinite integral. Any questions about that? Okay, so once we have the indefinite integral, now we can do the definite integral. And all we need to do is evaluate this function when u equals 4, and then when e equals 1, and then we subtract them. So let's write it out. The integral of 1 to 4 u minus 2 root u du. We are just going to take the function. We don't need the plus c anymore. And so we're going to evaluate this at 4 and 1, and then subtract them. So I write the vertical bar on the right side, and then 4 at the top and 1 at the bottom. So we're just going to plug in the upper limit first. So that's 2/3 times 4 to the power of 3/2 minus 4 times 4 to the 1/2. So that's the first one. And then I'm going to plug in 1 because that's the lower limit of integration. So I'll have 2/3 times 1 to the 3/2 minus 4 times 1 to the 1/2. That's my second one. And then all I do is subtract them. So if I do this out, I'm going to get 16/3 minus 8 minus 2/3 minus 4. And then if you did that, you would get
Yeah, that's so smart. Right below.
2/3. Somebody confirm?
Yeah. That all is from one bone.
It's not that much. Any questions? Yeah, I think it's correct. Okay, so just to review, we first took the antiderivative, which is the indefinite integral. And then we take that indefinite integral and we plug in the upper limit and the lower limit and then subtract them. It's very easy. Very easy. Okay, shall I do another one? Which one? 11's? Let's do 10. No, 10 is too easy. 10 is too easy. Let's do 11. Yeah, 11. 12 is also very easy. You can just look at it and you know the answer immediately. Does anybody want to explain why 12 is so easy? Hmm? So it's 0, right?
You understand Einstein's field equations?
I never learned general relativity. Okay, let's do 11. So we're integrating secant squared from negative pi over 6 to pi over 6, right? Okay, what is the antiderivative of secant squared? Thank you, tan x. You guys need to have this down cold. All your tangent, secant derivatives, you need to know that. Guys. Please be quiet. I want to continue for your sake. So we found the antiderivative, which is tangent x, and now we want to plug in the upper and lower limits of integration. So we'll write our vertical bar, and then our upper limit is pi over 6, and our lower limit is negative pi over 6. Okay, so all we do is we plug in the upper limit, so tangent of pi over 6, and then we subtract it after plugging in the lower limit, which is tangent negative pi over 6. And then what is tangent pi over 6? Let's see if somebody can say it.
That again. This question.
Tangent pi over 6.
It's square root of 3 over 2.
No, yes.
What was it?
It is root 3 over 3 or 1 over root 3.
What do you got left to give me?
Okay, how about tangent negative pi over 6? Yes.
So we need to know unit circles now?
Good news on the quiz, calculator is allowed. I would not have wanted it that way. It was misleading. It was misleading.
Can you show it for me and said how to find that one?
Yes. I'm actually very anti-calculator. My pre-calc accelerated, no calculator at all. No calculator at all. Okay, I'll do one more, but which one?
Let's do number 7.
7? 7 is a little easy.
All of them easy.
That is true. All of them are easy. Okay, I'll do number 7. No, 7's too easy. Come on. What's the harder one? Let's do number 8. 8 looks at least a little more tricky, right? Okay, so 8 is the integral from -1 to 0, t to the 1/3 minus t to the 2/3. All right, can anybody give me the antiderivative? Indefinite integral?
Eight.
What about Jack?
Minus
We'll get there.
anybody? Of t to the 2/3? Uh, uh, yes, good.
That's how Luca is.
Okay, and then we're going to evaluate this between 0 and 1. Sorry, -1, right? So 0 at the top and -1 at the bottom. Okay, so now all we need to do is plug this in. Obviously, if we plug in 0, we're just going to get 0 for the whole thing, so we don't need to do that. So it'll be 0 minus. All right, what is so we'll have 3/4 times -1 to the 4/3 minus 3/5 times -1 to the 5/3. I realize that you guys might struggle with this, so. All right, so what is -1 to the 4/3?
Question is, right, what is the line?
The line tells us that we first evaluate it at the top one and then subtract it when we evaluate the bottom one.
They just plug it in.
What is -1 to the 4/3? It is 1. What is -1 to the 5/3? Yes, -1. Okay, it's -1 because 5 is odd. So whenever you have an odd number in the numerator, after it's totally simplified, you're going to have a, did I say odd? It'll be negative. Okay, so the answer is -27/20. Okay, I'll stop there.